Hi everyone, welcome back to the channel. Today's video we're going to be going through the November 2022 higher tier non-calculator paper from Edexcel. Hopefully it's transmitting. There we go, yeah, it's working. Okay, so this is non-calculator paper, right? Because we're preparing, obviously, most likely your first paper in May will be non-calculator, so we'll be doing that for the next couple of weeks. The paper links for this one and the mark scheme are in the description of the live chat if you also want to open it yourself. Otherwise, obviously, we'll just go straight through it. So this is quite a common question, this one. It can obviously come up on the calculator as well, but I feel like it does seem to come up on non-calculator quite a lot, especially for Edexcel. So you've got here, write 500 as a product of powers of its prime factors. So we're basically just breaking it down into its prime factors. Now, sometimes they'll ask this, sometimes they'll ask about highest common factor, sometimes they'll ask about lowest common multiple, sometimes they'll ask multiple of those, but that's kind of the whole same topic. So this is just product of prime factors, so we just need to draw a little factor tree. Now there's a few ways to do this. The way that I do it is I just split it straight into prime factors, so not just any numbers that go into 500, but I personally like to look at specifically prime numbers. Some people just like to split it into any factors they can figure out and then break it down further into prime numbers. That's also fine. It's just whatever you prefer to do, basically. So prime factors, obviously, I normally start with, if it's even, I'll pretty much always start with 2 just to kind of keep halving it until it's no longer even. Then I'll have a look at 3 and 5, and then beyond that kind of see what's left, right? So yeah, we're going to split it. I just normally do 2. Obviously that makes it 250, still even, so I'll do 2 again, 125. And then now it's odd, then I go, oh, it's either going to be probably 3 or 5, most likely. In this case, obviously 5, get 25, and then obviously that's 5 and 5. So those are all, and then because I've done that, all of the ones on the left-hand side there, and including obviously this bottom one, are the prime factors. So, yep, we just multiply them together, and as you said, you put it as in the power format as well. So, as in, you've got 2 times 2 times 5 times 5 times 5. But in other words, if we were to use powers or indices, you've got 2 squared times 5 cubed. And that's it. So, yep, 3 marks. That's a really nice, easy 3 marks for that one. Question 2, this is also something that always, or pretty much always comes up on the non-calculated paper, some kind of fractions operation. So here we've got a plus and a divide. It could be obviously multiply, could be subtract, any of those 4. And they like to mix in the mixed numbers as well. I feel like they like to do that to make it a bit harder. So part A, work out 1 3/5 plus 2 1/4. And then they have specified that they want us to give our answer as a mixed number. So when it's add or subtract, if you want to, you can add the whole numbers and then the fractions separately. But when it's divide, so obviously the next one we would end up doing is divide, and it also has a mixed number. Divide or multiply, you do have to convert the mixed numbers into improper fractions. So it's up to you whether you just want to go, do you know what, for any of the types of fractions operations, I'm just going to convert them all to from mixed numbers into improper fractions, so that I don't have to worry about remembering which time I can and which time I can't. Or you might be happy to go, yeah, I'm just going to save myself some time by only adding the whole numbers and adding the fractions separately. That's completely up to you. That's just a personal choice, how much you want to kind of remember or however you feel comfortable. So I'm going to just convert them to improper fractions just so that they can see what to do in that case. Obviously, then it does make the fractions bigger in the numerators. So that's something to kind of consider. So to convert from mixed numbers into improper fractions or top-heavy fractions, we want to take the whole number, multiply by the denominator. So that first one will be 1 times 5, which is obviously just 5. And then the numerator is kind of like a remainder, so add that. So that would be 8 over 5. And then the other one we'd also do 2 times 4 is 8, plus 1 is 9, so 9 quarters. Now, obviously, when you're adding and subtracting any fractions, you have to have a common denominator. So the lowest common multiple of 5 and 4 is 20, which in this case means I have to change both fractions. So to go from 5 to 20, I obviously multiply by 4, so I also need to multiply the numerator by 4, which is 32. And then to go from 4 to 20, I need to multiply by 5, so 9 times 5 is 45. So you can see you do end up with kind of quite big numbers here because I've included the whole numbers as well as part of the fraction. So you might prefer to just add the 3/5 and the 1/4, for example. But as I said, that's just up to your decision. That's just a personal preference. So now I can add them. I obviously just add the numerators, not the denominators. The denominator is still 20. So we add them and we should get 77. But they have said you need to give your answer as a mixed number. So if you have converted it into an improper fraction like we have here, you're going to have to convert it back as well. So obviously the opposite is then going, well, how many times does 20, my denominator, go into 77? How many times does it go in as a whole, whole amount? Well, it would go into 60, wouldn't it? Which is 3 times. So 3 is my whole number. And then whatever's left over between 60 in this case and 77 is 17. And then you can see if you simplify it, but you obviously can't. They haven't even mentioned that either because they know that you couldn't simplify. So 3 and 17 over 20 is your answer, part A. Part B is then similar. We've just got a divide, and they have actually given us the answer, so at least you know if you're correct because you should get the same thing. So show that 2 2/3 divided by 6 as a whole number is equal to 4/9. Now, the first one we do need to convert into an improper fraction. So again, 2 times 3 is 6, plus 2 is 8. So that's 8/3. And then you either divide it by 6 as a fraction. So any whole number you can convert into a fraction just by putting it over 1. And then you can do keep flip change. Or if you're happy with knowing that dividing a fraction by a whole number, you just effectively multiply the denominator by that number. It's whichever method. Again, there's so many different ways to do these questions. So if I show you keep flip change, because that's a more consistent method, obviously you would keep the first one, flip the second one to get 1/6, and then change it to a multiply. And you can see how then the only thing that's affected is the denominator. Still 8 and then over 18. So that's the answer, but they have obviously shown you that it could be simplified. You can see they've obviously just divided by 2, so you can write that there for 2 marks. Okay, so the main thing with this one, I guess, is the whole number. To convert a whole number into a fraction, just put it over 1. Any number over 1 to make it a fraction. So that's question 2, fractions. Question number 3, we've got index laws. Again, this is most likely to come up in non-calculator because they want to know that you didn't just type it into your calculator. So we've got simplify 2 to the power of -5 times 2 to the power of 8, and then all of that squared. And then we need to give our answer as a power of 2. So we're not working out the value, we're just actually going to simplify it, basically. So we're using index laws. I'm going to do inside the brackets first. When you have to multiply, and they both have the same base number, so you see how I've got 2 and 2, obviously, I can just add the powers. So -5 plus 8 would be 3, 2 to the power of 3. And then it's still squared, isn't it? So then this is my third index law, which is the one with the brackets. So that's where you multiply the powers. So then we get 2 to the power of 6. Now, they don't want you to work out 2 to the power of 6. They want you to leave it as 2 to the power of 6 as a power of 2. If it ever says work out the value, then you would actually then have to work out what is that number. What is 2 to the power of 6 as a number? But they haven't said that, so that's fine. Okay. Question 4, work out 0.004 times 0.32. Now again, multiplying or dividing decimals is going to be something that's likely to come up in the non-calculator papers because again, they want to see that you can do it without a calculator. So the way that I do this is I just make them both whole numbers. So for example, the first one, I would have to move the decimal place 1, 2, 3 times, wouldn't I? Which is the same as timesing by, let me write that again. Timesing by 1,000, isn't it? And then the second one I'd have to times by 100. So I'm just writing that there. So I'm actually going to do 4 times 32. So I'm leaving that there because we'll come back to it at the end. Obviously, if we're going to make the two numbers bigger, we're at the end having to then make them smaller again. So that's why I've written those there in pink. You can multiply this however you want. I just basically doubled it and doubled it again. You could obviously do column multiplication. I just said, well, 32 times 2 is 64, and then 64 times 2 is 128, so that's 4 times 32. That's how I did it. But if there's a more complicated one, you might want to use column multiplication. Just make sure you remember how to do that. Now, obviously, the answer isn't 128 in that format, is it? Because that's way too big. So I come back here and I say, well, how many times did I move my decimal place in total with both? Do you see how I moved it 3 times for the first number and twice for the second number? So in total, that's 5 times. So I'm going to have to move it 5 times back. So currently the decimal place is here. 1, 2, 3, 4, 5. That's my new decimal place. And then you see, obviously, you get 0 here and 2 zeros here. That's how I figure it out. Just count how many times you changed the decimal place originally for both together, and then apply that to your answer. So 0.00128 should be your answer. Okay, so now we've got a worded one. A car factory is going to make 4 different car models, A, B, C, and D. 80 people are asked which of the 4 models they would most likely buy. The table shows information about the results. So you've got obviously car model A, 23 out of the 80 people would rather choose that one. B, 15 out of the 80 would choose that one, and so on. They've then said that the factory is actually going to make 40,000 cars next year. Work out how many Model B cars the factory should make. So it's kind of like the population sample one. They've obviously taken a small population sample, 80 people, and then they're going to apply the proportions to an actual bigger amount, so the actual whole population. So in this case, we're looking for B. Do you see how B is 15 out of the 80 people in the sample? So that is then the proportion, isn't it? That's the fraction. And I want to apply that to my 40,000. Now, obviously, if I had a calculator, that's how I would type it in, but in this case, we don't. So I would probably work this out. You can obviously go straight ahead and divide by, you always divide by the denominator times by the numerator. You could go straight away and do that, or if you want to, this fraction does simplify. So you might prefer to simplify it first, you might prefer not to. Again, that's up to you, kind of what makes more sense to you. I think I did simplify it. So they both divide by 5. So 15 divided by 5 is obviously 3. 80 divided by 5. When you're dividing by 5, you can divide by 10 and then double it. So as in, divide by 10 is 8, double that is 16. Or, obviously, you can use bus stop division if you wanted. So that's the simplified version. So what I actually need to do is divide by 16, which still doesn't seem that great, but anyway, and then times by 3 at the end. So I'm probably going to use bus stop here. Obviously, you put your 40,000 inside, and then whatever you're dividing by goes on the outside. 16 obviously doesn't go into 4, so I'm just going to skip that and go straight to 40. Right, 16 goes into 40 twice. That would make 32, wouldn't it? And then the remainder is 8, so that goes there. And then now we've got 80. 16 goes into 80. Well, we've just done that, haven't we? We did 80 divided by 5 gave us 16. So 80 divided by 16 is 5. That's kind of the same thing. So I get 5 here, and then obviously because there's no remainder, I just have 2 zeros. So that is divided by 16. That's effectively 1/16. I want 3/16. So then I need to do 3 times 2,500. Okay. Now you might, oh, I added another 0 there. You might just add it up, because 3 is not that many to multiply by, or you might want to use column multiplication again. The way that I did it was I just knew that 25 times 3 is 75, and then obviously add the other 2 zeros. So I didn't even use column multiplication. But you can do. So your answer should be 7,500, because that is 3/16, or 15 out of 80 of the original 40,000. So you're just applying that fraction, that original fraction that represents your population sample, you're applying that same fraction to the actual population. And this one, 2 marks, which I think is kind of mean. I feel like there should be more marks than that, considering it's non-calculator. But yeah, anyway, any way that, or any method that you used, even if it was different to mine, if you've got 7,500, you'll get the marks. Okay, so question 6, Rizwan writes down 3 numbers A, B, and C. We've got the ratios now. So we've got A to B is 1 to 3, and then B to C is 6 to 5. First of all, we need to find the 3-part ratio A to B to C. So whenever you've got this, where you've got 2 separate ratios, obviously you see how B in this case overlaps. One of the letters or whatever it is, one of them has to overlap. So you've got B in both, and then they want you to create a 3-part ratio. What you have to do is compare, in this case, the B numbers. So I like to write it out like this. This is just how I do it. You don't have to do this necessarily. If you like to write it out in a different format, that's fine. So I put 1 to 3, and then below that, because that's where it overlaps, isn't it? 6 to 5. So looking at just the B's, they're not currently the same scale, are they? One is 3, one's 6. So I need to make them same scale, kind of like where we did this, the same denominator, common denominator for fractions. It's the same kind of concept. So what's my lowest common multiple of 3 and 6? Well, ideally the lowest one, because then you don't have to simplify at the end. If you just find any common multiple, it will work, but then you would have to simplify afterwards. So the lowest common multiple of 3 and 6 is just 6 itself, isn't it? So I don't need to change the second one, but what I do need to do is change the first ratio. I need to multiply that by 2, and obviously you do the same to both sides. So A to B, before it was 1 to 3, I want to make the B 6, so obviously I need to then make the 1 2. And then now, because they're both, B's are both 6, it's the correct scale, so A would be 2, B is obviously 6, and C is 5. Now, if you have to change, you know, if your lowest common multiple is different for both ratios, both numbers, you'd have to change both ratios. Same as if you have a common denominator with your fractions. But in this case, we only had to change one. So 2 to 6 to 5. Part II, express A as a fraction of the total of the 3 numbers A, B, and C. So now we've got this ratio. You kind of have to have that ratio in order to do the second part, which is obviously not great if you weren't sure about how to do part AI. You can't then do II. So converting any ratio into fractions, doesn't matter if it's obviously 2 parts or 3 parts, doesn't matter. You always take whichever one you're looking for. So they said A, you take that number as the numerator. So in that case, that's 2, isn't it? That's the A one. And then you add up all of the other parts, whether it's 2 parts or 3 parts, you add them all up. So that would obviously be 2 plus 6, which is 8, plus 5, which is 13. You can obviously simplify it. If you could simplify, in this case we can't obviously simplify, but sometimes you can. So you can go ahead and do that if that's the case. So 2/13, that works for 2-part ratios as well, or 3 parts, it doesn't matter, it's the same thing. So take the numerator that you want. So in this case we wanted A, so that was our numerator, and then the denominator is always all of the other parts added together. Okay, then we got part B. Emma writes down 3 numbers, M, N, and P. They've given us kind of like equations. So N is equal to 2M and P is equal to 5N. So you can see again, they've overlapped the letter N. That's the one that's in both. And then it says, find M to P. I'll just quickly answer the question. If I do it, I don't actually do A-level maths. Right now I'm only focusing on GCSE. So yeah, sorry about that. I don't actually do A-level, just up to GCSE. Okay, so we need to find the ratio of M to P. So what I did was we obviously want to get both of these equations into one, but we therefore don't want to have N, which is fine because N is the one that overlaps, isn't it? So do you see how what I could do is I could substitute, if they said that N is equal to 2M, I could substitute the whole of that first equation, as in the 2M, into where it says N. So I could write it as P equals 5. Instead of N, I can write 2M, because that's the same thing, isn't it? P is equal to, and obviously that makes 10. M. Now they've said M to P, so I'm just going to write it the other way around just so we can look at it. So how do we then convert an equation back into a ratio? This is just something to memorize. If you've got it written like this, where the letters are on, both sides, you've got M on one side, P on the other side, you effectively just take the coefficients, so 10, and then this one's technically 1, isn't it? You have to swap them, and then that's the ratio. So as in this case, because M to P, that would be 1 to 10. So that's why I wrote it this way around, so you could compare it. So if you've got an equation, as long as you've got the 2 letters on, different sides of the equation, you can then take the coefficients and just swap them. That creates a ratio. That's just something to memorize, basically. Some other people like to have it in a different format. They like to have the fraction. So for example, if I put M and P on the same side, so I've divided by P and then divide by 10, then you can see that in that case it would be straightforward. M is 1 and P is 10. You can do it that way as well. Whichever version of that fraction you want, just memorize whichever version and then how it therefore translates into a ratio. Okay. So that's just something to know. So that whole question is 6 marks for ratios. Okay, question 7, we've obviously got a pressure question here. So they've given you the formula. You don't need to memorize this formula because they will give it to you. However, I know density, mass, and volume is kind of, I mean, it's not the same thing, but it's kind of similar in terms of the formula. It's kind of similar. That one, they won't give it to you. Okay, so they've given you the pressure one, but they won't give you density, mass, volume. So that one you have to memorize. Okay, so a storage tank exerts a force of 10,000 newtons on the ground. So we have the force. The base of the tank in contact with the ground is a 4 meters by 2 meters rectangle. So that would actually, we can obviously use that to work out the area. And then they said work out the pressure on the ground due to the tank. Okay, so before I can work out the pressure, what I actually am going to need to do is obviously work out the area before I work out the pressure. So I need to do area. It's just a rectangle, isn't it? So that's just base times height, as in those two measurements they've given you. Multiply those together. You've got 8 meters squared. And now that we've got the area, we can just put it, because they've asked for pressure, we can just put it straight away into that formula. We don't need to rearrange. So we've got force is 10,000 and the area is 8. Now, obviously I need to actually work out what that is. You can obviously use bus stop division, but dividing by 8, it's the same as, you know, when you divide by 2, divide by 4, 8, 16, so on. It's basically just half it to divide by 2, half it again to divide by 4, half it again to divide by 8. So you could do that if you want, just half it 3 times. You could do that. Or you can obviously use bus stop if you want to just stick to the same method. But I just basically kept halving it. So I went, well, half of 10,000 is 5,000. Half of 5,000 is 2.5, and then half it again, because that would have obviously been just by 4. Half it again would be 1,250. Okay, so however you've divided it, that's fine, as long as you get this answer. 1,250. And the units match up, right? You see how the answer says newtons per meter squared, so we don't need to worry about changing any newtons. Okay, question 8. So we've got here two numbers m and n are such that they've said that m is a multiple of 5 and n is an even number, and also the highest common factor of m and n is 7. So write down possible value for m and possible value for n. Now obviously you can kind of just test things out if you want, but the way that I actually worked this out in a little bit, kind of a bit more of a method, I guess, was I used the logic of the highest common factor. And I kind of just reverse engineered it. So normally the way that I work out highest common factors, I do, you know, question 1 we had product of prime factors. I break down both numbers into a factor tree, then I fill out the Venn diagrams. What I'm going to do is just do the opposite of that. So you don't have to do it this way, you can just test out answers if you want until you get the right number, that's also fine. Oh. But I kind of just did it in a way that was a little bit more structured, I guess. So let's say this is m, this is n. Now they've said that the highest common factor is 7, which is the bit in the middle. The highest common factor is always the bit in the middle. So we've got question 7 here. We've got number 7 here, sorry. There's nothing else in the middle because that is the highest common factor, and the highest common factor is always anything in the middle multiplied together. So that is just 7, isn't it? Because 7 is a prime number. Then I looked back at these other two things and I said, right, they've said that m is a multiple of 5. Well, 7 is not itself a multiple of 5, is it? Obviously it's a prime number. So I thought, well, you'd have to have at least 1 5 here, because anything multiplied by 5 is a multiple of 5, isn't it? That by definition, if you've multiplied a number by 5, it becomes a multiple of 5. And then n is an even number. Now, in terms of the same logic, even numbers are multiples of 2, always. So I just put 2 here, which is also a prime number. That's what I did. And then I went, right, okay, so then m is like obviously this whole bubble here. So I went, okay, well that's 5 times 7, which is 35. And then n is this bubble here, which is 7 times 2, which is 14. That's how I kind of worked. You don't have to do it this way again. You don't have to. But that's how I worked it out, just to have a little bit more of a structure. But you could obviously do trial and error. Just keep testing out numbers. And that might also be quicker. That might also take you longer. I don't know. It just depends. So 35 and 14 are obviously examples. They said write down a possible value of m and a possible value of n. So that means there's more than obviously just one pair of example answers. So I'm going to have a look at the mark scheme and I'll show you what possible answers you could have had. So their kind of initial option was this, 35 and 14. I think that's the most obvious option. But they have said you could have had 35 and 28. You could have had 105 and 14. It's basically that m is 35 or 105, and then n could be 14, 20, any of the 14 times tables. So 14, 28, 42, 56, 84. And then 105, it could be 14, 28, 56, 98, you know, anything like that. But these are kind of the first ones you think of. Sorry, I just looked at the comments. One of them, I didn't quite catch your comment. I don't know if you want me to look at that again. Okay, question 9. So this is a really nice one. Complete the table of values for y equals 6x minus x cubed. It's going to be a cubic graph. So for this one, we just literally need to substitute in each of the values of x. So you just have to work it out as in, so let's start with minus 2. Just be really careful with any negatives and positives. So we've got 6 times minus 2, because obviously that's saying x is minus 2, so sub in x there. Minus, so subtract, minus 2 cubed. So just be really careful with all these negatives. So obviously that one there at the start is minus 12. And then this here, minus 2 cubed is minus 8, but then they've subtracted it. So you see how that would become plus 8? So just be really, really careful. So you've got minus 4 overall for that one. And then you just do it for the other three, basically. So y is equal to 6 times minus 1. Take away minus 1 cubed. So y is minus 6. And then minus 1 cubed is minus 1. Times it by a negative becomes plus 1, doesn't it? So then you should get minus 5. Luckily the 0 is easy because they're all x values, so if you times anything by 0 you get 0, and then you just got 1 to finish with, so 6 times 1 minus 1 cubed, which is obviously just 6 take away 1, which is just positive 5. You can also kind of see they've chosen numbers nicely here, so 9, minus 4, minus 5, 0, and then positive 5, positive 4, negative 9, you can see they've swapped. And then you just basically have to plot those coordinates on the grid. So that's also really nice. Okay, so from your experience, what coping methods would you recommend to get back on track with your studies and to improve on what you lack in? I think, yeah, it's quite difficult, isn't it, if something's happened or you've just had time off or something that you didn't expect has come up before the exams. That's quite hard to kind of get back on track. I mean, ultimately, I guess it's more in terms of GCSE, I guess whether this relates to A-level or not in the same way, I don't know. But in terms of GCSE, it's more, I think it's more the motivation that you don't want to have to do it again, is what I would say. As in, especially maths and English, if you don't pass maths and English for GCSE, that you have to end up, you might move on to college, but you still have to also at the same time redo them. And I thought like that's surely quite good enough, you know, quite good motivation to try and not have to redo it. It depends what's happened, because sometimes something comes up that's, you know, really bad and you can't kind of bring yourself back and you have to just come back the next year. Depends kind of what has happened, doesn't it? You know, sometimes it's more, whatever's happened is more important than your exams, you know, and sometimes it isn't, and you have to try and kind of drag yourself back into it. I think yeah, it's just more just thinking, well, you know, what it depends, because it depends on the situation, and I understand like mental health and everything. You can't just like necessarily snap back out of it and just make yourself study if you are not in the place to. It really depends what has happened. But I would just say, like, what would, you know, just thinking of your future self, especially because the exams are so close, and even A-levels as well, I think mostly are in June, but even then that's I mean, I'm assuming they'll be done in like 2 months' time. So it's kind of thinking, well, what can I do for the next 2 months, because it's getting close now? What can I do just to then give myself the best chance at whatever you wanted to do with your future, whatever you wanted to do after this? Because also A-level, you really don't want to have to redo A-level. Not that they would make you. You know, it's not the same as GCSE, but you don't want to. I wouldn't suggest you wanted to. I think A-level was really hard. So yeah, maybe it's just that. Just go, I don't want to have to redo this. I don't want to have to spend another year and come back to this. Maybe, you know, coping methods specifically. I mean, it could just be trying to set yourself try and be realistic about, don't set yourself too much. Let's say in the first week, let's say this is your first week at trying to get back into things. Don't try and give yourself don't get too stressed out about everything you need to do, just little steps at a time. And maybe you'll kind of be able to ease yourself back into it. I know you don't have a load of time left, but, it is the time is now, isn't it? It's either now or next year. That's kind of the option you've got. It's either we're going to try and do our best this year, or we're just going to have to leave it and come back next year. I don't know which of those options is best for you. Sometimes it is best just to come back the next year. It just depends on what your situation is. But yeah, I would assume you probably don't want to have to retake. I don't think anyone wants to retake, particularly if they can avoid it. So yeah, I would just maybe start off this week and go, what small thing can I do every day? Even if it's not that much, just to get yourself back into it, and then each week or each day you just add a little bit more. So just, yeah, don't kind of beat yourself up about it. Just see what you can do today, a little bit today, and then maybe a little bit more tomorrow, and just see how you go. Speak to your teachers if they've got like after school tutoring, not tutoring, you know what I mean? Like they've got after school clubs where they're going through revision. That might help rather than just being on your own trying to do it. Or if you could maybe do revision with your friends, or maybe that would help. I don't know. Yeah, without more context, I guess. Not sure. It's just more your motivation to kind of get through this and not have to retake, I would suggest, is probably hopefully what would drag you through it. But A-level is hard. Generally, it is really hard. So yeah, just doing your best, really. It is really hard, A-level, I think. Okay, so let's just fill this in. So I'm going to try and draw it obviously on a piece of paper. You can do a lot of a better job than I can, but you just need to plot it. So can we still see those coordinates? Just make sure you can see it. Obviously on your piece of paper you'll be able to see it. So the first one, -3, 9. So just be careful with the scale, because 9 is literally halfway through. It's not really on one of these lines, is it? Horizontally, it's kind of halfway. So just kind of be careful with that. -2, and then it goes to -4. So right down here. Then -1, -5. Then it goes back to 0, 0. 1 to 5. So 5 is also... Oh, I put this in... I was going to say, yeah, I was about to say be careful about the 5, but I also put the other one in the wrong place. -5, yeah, just be really careful what the scale is. And then, so 1, 5, so that's, again, halfway. 2, 4. So try and make sure it's actually on the line, that'd be good. And then 3 is then -9. Okay, so as best you can. Now, obviously, join it up in a curve. Mine's going to look really horrible because it's digital, but you can obviously do a better job. Obviously, do all of your graphs with pencils, right? So if you need to rub it out, you can. Don't just go straight into it with your pen. Okay. Luckily, we don't have to read any values off of it. Oh, that was horrible. But you'd obviously get the point. You'd do a much better job than I would. Something like that. It should look kind of like this kind of shape, basically. That's a cubic graph. Okay, that's 4 marks for both of those. So you're just subbing it in and then plotting it. That should be really nice. Doesn't matter which type of graph it is. It's always the same method. Okay, question 10. So Lena spins a biased 5-sided spinner 40 times. Here are her results. Obviously, the frequency, that row there would add up to 40. And then the scores is obviously all the numbers that they have on the spinner. Lena is now going to spin the spinner another 2 times. Work out an estimate for the probability that she gets a score of 5 both times. So we first need to know the probability, it's obviously an estimate, but the probability of getting a 5 once. So the probability of getting a 5 once if you look at this table, so 5 is here, she, out of 40 times, she got a 5 10 times. So do you see how that, as a fraction, as a proportion, or as a probability, 10 out of 40, which you can obviously then simplify. So this is our estimated probability, that it's probably roughly about a quarter chance of getting a 5, is what we're saying. Now that's once, though. They've said that she spun it twice. So this is where I think of, you don't have to draw a probability tree at all, but the logic is there. She spun it once, the probability of getting a 5 is 1/4, and then she spins it again, and the probability again is 1/4. So if you think about a probability tree between the branches, so let's say we're saying land on a 5, land on a 5 again, between those two branches is always multiply. So what we need to do is just a quarter times a quarter, which is 1/16. It doesn't, you could do 10 over 40 times 10 over 40 if you want, but I would probably simplify it so it's a smaller number to deal with. So you should get 1/16 there. Quarter times a quarter. It's not add, it's times, because we're saying 5 and 5, which is the and rule, which means multiply. Okay, then it says Derek is going to spin the same spinner a large number of times, work out an estimate for the percentage of times Derek can expect to get a score of 1. So looking back at our table, it was 6 times that they got 1. And remember, that was out of 40, wasn't it? 6 out of 40. So that's our fraction, but obviously they want to have it as a percentage. So they're just saying you need to convert this into a percentage. Okay, so whether you make it into a decimal, obviously times it by 100 to make it a percentage. I simplified the fraction. So first of all, I said, right, 3 out of 20. And then you could divide that with bus stop, or if you already know what that is as a decimal, then perfect, that's fine. So let's just say that we don't. 3 obviously doesn't go into 2. 3 into 20 goes in... Oh, divide the other way around. I was thinking why that was too easy. There we go. Make sure you obviously put it the right way around, otherwise the numbers won't add up. So how many times does 20 go into 3? Obviously none. That's why we should end up with a 0 here. And then we're carrying over the 3, which is then 30. That goes in once with a remainder of 10. And there's another 0. How many times does 20 go into 100? Well, that's 5. And there's no remainder, so that's our answer. So we've got, as a decimal, 0.15, which then, to make it into a percentage, you obviously just times by 100, don't you? Any decimal to a percentage is times by 100. So you should get 15%. Okay, question 11. So it says, describe fully the single transformation that maps shape P onto shape Q. Now, this one is fairly straightforward. You just have to be really careful which way around they've done it, because I feel like naturally, like I would, without properly reading it, I would probably think, how do I get from the small one to the big one? I feel like that's more natural, isn't it? But they've actually said in this case, P to Q. So we're saying the starting at the big one, getting smaller. So just really double check which one they've said, which way round, which letter is the first shape, which one is the second shape. So it's obviously got smaller, which is still called an enlargement. It's just obviously the scale factor is going to be smaller than 1. So even if it's got smaller, if it's changed size, it's still an enlargement. Now if I scroll down a bit so you can see the marks. 2 marks. So obviously enlargement is one of those marks, but you have to also mention some more details about the enlargement. So information that we can give about an enlargement is, obviously, as I mentioned, the scale factor. How much has it either got bigger or smaller by? And also the centre of enlargement, because we've got these axes. So that's 2 more pieces of information we now need. So the scale factor is pretty easy because you just look at one of the sides. So this one, let's say here, that was 3, it's now 1. So do you see how it's got 3 times smaller? So I'm going to go scale, I just put SF, you can put scale factor as words if you want. 1/3, isn't it? It's divided by 3. 1/3. And then the last thing is then the centre of enlargement, which can be kind of hard to figure out, but all you need to do is get, if you've got your ruler, I grab a straight line here, and just join up the corners, as in, but extend your line further. So make sure you get the same corners, right? So this top corner is the same as this one. and just extend it the whole way, so you can kind of see where it's probably going to be the center of enlargement. So where they all overlap, so that's that corner to that corner, you can see where they're starting to overlap now, can't you? That corner to that corner, and then obviously make sure you've matched up the correct corners, right? Otherwise it won't work. So you can see that the center of enlargement as coordinates would be 0, 2. So those are the 3 pieces of information we need. What type of transformation is it? And then information about that transformation. Enlargement, scale factor 1/3, which means it's not only got smaller, but it's also got closer to the center of enlargement and then the center of enlargement. And that's 2 marks. Okay, let me just come back to the questions. Okay, so you've got resources on YouTube. Yeah, the motivation is hard. I guess it depends what, I don't know if you're year 13 and about to finish A level or S1, yeah. Because it's kind of hard to find the motivation in year 12 because it's not necessarily as serious, is it? Year 13, I think it's more like, I don't know what you want to do after this. Because for me, when I was in A level, obviously I didn't really want to be studying, but I just knew kind of what I wanted to see on results day. And I was, like, for example, what university I wanted to get into. I don't know if you're looking to get into uni or do something else. Oh, yeah, that's kind of hard then, isn't it? Yeah, it's not as motivating then, I guess. So are you year 12? Is this like a mock exam? Yeah. Yeah, okay, I was going to say, I feel like year 13, you just naturally feel the pressure because you're, like, that's the last thing. Yeah, probably for year 12, I don't know if your school has rules on the fact that, like, let's say if you don't get these certain grades, you have to Oh, you're year 11. Year 11, well, at least, I don't know if you're from the UK. Year 11 in the UK does GCSE, but you're saying you're doing A level. Is it, okay, so what I mean by that, is it the first year of A level or is it the second year? Because normally it's 2 years, isn't it? That's probably what I mean. I'm assuming it's the first year where you do kind of you do internal exams. S1 sounds like statistics 1, but I don't know if I'm just making that up. It might stand for something else, but I was assuming it meant statistics 1 for maths, A level maths. Because you can do international A levels, can't you, as well? That's I'm assuming what you're doing, international version of the A levels. Yeah, S1. Okay, I'm assuming that you're in your first year of doing the 2-year qualification is basically what it is. I don't know if your school has said if you don't get these grades in your internal exams, then you can't move forward into the second year, because that would surely be a decent amount of motivation. I don't know if they've said that. Or if they just let you carry on whatever grade you get, I don't know, because then there's obviously not as much motivation if they've just let you carry on. Because what I would suggest is A levels. Like I said before, I wouldn't want to retake any of the years personally. So that would be my motivation, is that I just wouldn't want to retake. The other thing is that I didn't do very well in my first year of A levels, and then the second year is when I pulled it back. So if something's happened this year and it's just not your time, like at the same time, it might not be the end of the world. You might just go, do you know what, next year I'm just going to come back and do better, because that's what I did. I didn't do very well in my first year, and then my second year I kind of got my head down, and then I actually did better. Yeah, it really depends. You could just make a list of your resources on YouTube, so how many that you want to go through, how many days have I got, okay, therefore that means I need to do this many days. But again, it is down to motivation, isn't it? I don't know whether you've got someone that you can study with and they can kind of be the person that keeps you accountable, or if your parents can keep you, or someone that's, someone in your life that can keep you accountable. That might also help, because I know motivation is the hardest thing. Okay, I'm going to carry on with this, but feel free to keep sending messages, that's fine. So, question 12, solve the simultaneous equations. These are just linear, so that's nice, they're not quadratic. But the issue are the coefficients. So linear simultaneous equations, you can either use substitution method or elimination method. That's a complete personal preference again. It's up to you. I normally stick with elimination. I don't know why, I think I just prefer it, but you might use substitution. also fine. If we get the same answers, that's fine. So I'm going to go through with elimination because that's what I naturally tend to do. When we're eliminating, we obviously want to get rid of one of the letters, so you're going to look at the coefficients and go, which are the easiest to make the same, because it needs to be the same coefficient to make 0, right, to cancel out. So again, we're looking back for the third time now at lowest common multiple. So you got 5 and 4. Lowest common multiple would be 20, which means I do need to change both. And then 2 and 3, lowest common multiple is 6, which means I also need to change both. My choice was to make the y's the same, just because making 2 and 3 6 is smaller than making 5 and 4 20. But it doesn't matter. That was just my choice. This is, again, all up to you, what you prefer. So what I'm going to do is we have to change both. The whole equations, not just the y bit, right? So I need to multiply the first one by 3 to make it 6y, and the second one by 2. So the first one, everything times by 3, 15x plus 6y, and then obviously 11 times by 3 is 33. And then the second one, everything times by 2, 8x, again, plus 6y, that's the whole point. And then equals 12. Now you have to figure out, do I add and subtract? That is, you can obviously figure it out, how do I make 0 from both of these, but there are acronyms. SSS, that means if they're the same sign, you subtract. See how they're both plus? The y's are both plus, so that's the same sign. DSA, different sign add. So in this case, they're both plus, so I'm going to subtract. So 15 minus 8 is obviously 7x. The whole point is that in this case that the y's cancel, and then 33 minus 12 is 21. Now you've got an equation with just x. Okay? Or you might have an equation with just y if you decided to get rid of the x's. As long as you've got an equation with just one of the letters, that's the whole point, isn't it? That's fine. You can also send me an email. I think my email might be on my channel. That's absolutely fine if you want to send me an email with more questions. Okay, so obviously then I've got 7x is equal to 21. That's just a normal linear equation. So I'm going to divide by 7 on both sides, which gives me x is 3. So we've got 1. Once you've got the first one, then the second one is really easy. And it's the same for both methods. Choose one of your original equations, doesn't matter whichever you think looks easier. I'm probably just going to choose the first one and sub in x as 3. So instead of 5x, I'm going to write 5 times 3 plus 2y equals 11. Okay, and now just see how I've got an equation with the other letter. In this case, for my example, the other letter is y. You might have found out y first and then subbed it in to find x second. That's fine. So we simplify this to make 15. And then obviously I've just got a linear equation again with just y. So I'm going to move 15 over by subtracting. So 2y is minus 4, and obviously then divide by 2 is minus 2. Just be careful, it is a negative. Make sure you don't miss that out. Okay, my next live is on Wednesday. Monday, Wednesday, Thursday are my lives for past papers. These are higher tier past papers though. You're saying you're doing grade 3. I don't know. Are you on grade 3 but doing higher tier, or are you on grade 3 doing foundation? Because these are higher tier papers. I don't know if you're also doing higher tier. Okay, so 3 and minus 2, whichever method you use, as long as you get those answers, then it was most likely correct. 4 marks. Okay, question 30. Oh, you're doing higher. Okay, perfect. So these papers do make sense to you. Grade 3, you're on grade 3, so you only need to go up by 1 grade to pass. I'm assuming you're just aiming, like, obviously to pass. Yeah, I think so. The grade boundaries aren't really that high for higher tier. Honestly, it's not massively high. I think what I would recommend is, I have got a video, I think it should be linked in the description, the first one linked, is how to boost your grade. Now, originally I posted it like 3 months ago, but I think the information still is relevant even now. So I would have a look at that first, because there's different tips on how to boost your grade, whatever grade that is, how to kind of maybe go up by a grade or 2 grades. Have a look at that and then take the tips from that video. One of them is that I have a playlist on topics for higher tier that I would say are kind of easy marks. So just ones that I would go through that playlist on my channel that says topics, something like topics to gain easy marks. Have a look at that, go through those videos, make sure you know how to do those topics, because just as a reminder, just make sure you got those set, and then you might gain some marks from those. There's also a playlist called topics you might have forgotten about. There's certain topics that that are maybe stuff you did in year 7, year 8, but technically also still come up in the papers and you might have forgotten about them. And obviously, if you can get those marks, that's also additional, isn't it? It's all about just gaining more marks, isn't it? So yeah, I do think you can do it. I just think obviously you're going to have to really be strategic about it. So check out that first video. Anyone who wants to boost their grade, have a look at that video. It's linked in the description. And in the next, I think, maybe next week or the week, probably next week actually, I've got some videos coming out which are specific to non-calculator paper, which is obviously your first one. And it's, I think I've got one that's most common Edexcel questions for non-calculator. So it'd be quite good to watch that, because then you can say, well, you know, what's most likely going to come up. But we obviously can't predict it, but what's most likely, you know, what's quite repetitive. I've got a whole series right now which is the most repeated questions on different topics. They're all higher tier ones. So you can have a look at those, because if you can get down these questions that are repeated quite often, that's going to gain you more marks, isn't it? So yeah, have a look through my whole channel, have a look at what videos there are, especially the most recent ones, because those are kind of specifically geared towards hopefully helping you with your exams. But yeah, you just have to really, really want to, basically, don't you? Be strategic about it, figure out what you can improve easily, and things that maybe are too difficult to improve, just leave them. And focus on something that is easy to improve is what I would suggest, trying to figure out what's best use of your time, isn't it, as well. But the second 2 papers, you've still got quite a lot of time until those, relatively. So yeah, just really focus on the non-calculator. Have a look at those videos where I'm showing you what is the most repeated questions, which questions tend to come up the most. Those are probably going to be helpful as well. Okay, let's get on with question 13. So this is actually a really nice one if you're happy with proportion. So P is inversely proportional to T. We need to complete the table of values. So proportion questions tend to always be structured in, or at least you're working out, should be structured in 3 steps. Step 1 is always the equation, the formula. You have to have this memorized, right? So the formula for inverse proportion, normally we obviously use y and x, is y is equal to k over x. Remember which way around it is. Now, obviously here they've used P and T. Yeah, I think it's possible. If you're already on a 3, you're only trying to go up by 1 grade, aren't you? I'm not saying it's like super easy, but I'm saying I think it is possible, but you do have to obviously put the work in. Like, it's not just naturally going to happen. If you can really get your head down and really focus on it, and do as many past papers as possible and figure out where you're losing marks and improve specifically on those things, then yeah, I think it's possible. Definitely. So in this case, just swap the y and the x for P and T, just put it in the order that they've written it. So P is first, P is equal to K over T. Now, they will always give you a matching pair. What I mean by that is a pair of values that you then can sub in, because you need to work out what K is. You see how the matching pair in this case is the 100 and the 1. When T is a 100, P is 1. That's a matching pair. So step 2 is you sub in the matching pair, so make sure you put them in the right way around. So 1 first, and then K over 100. See how now I can just solve this to find K? So I'm just going to multiply by 100, obviously, to move it across. So K in this particular case is 100, so rewrite your equation. So therefore, P is equal to 100 over T. Okay, perfect. Now that I've got my equation, step 3 is then answer the question, which in this case means fill in the table. So do you see how the first one, we know that T is 25. So I'm going to write down my equation, but where it says T, I'm going to put 25. Do you see how now I can just solve that? Well, basically just work it out, actually. You don't even need to rearrange it. 100 divided by 25 is 4, so P is 4. And then I just go along to the next one, do the same again, but obviously now I know that P is 5. And I need to work out T. Now this one is the one that I think people get mixed up with, because they think they just need to divide by 100, but it's not that. The letter you want to solve for, you can actually move it. So see how, because that's in the denominator, I do need to move that letter. So I'm going to multiply by T. And now you can see what to do. I can then divide by 5. So just be really careful with that one. Some people aren't so sure about how to solve that version of it, which is 100 divided by 5 is obviously 20. Okay, and then the last one. Now you've kind of got the point of this, you know, this is just repetitive, isn't it? P is equal to 100 over 2, which is obviously, don't need to rearrange again, is 50. There you go. So it doesn't matter if it's a table, it doesn't matter if they've just given you information written down, it's always these 3 steps. Formula, work out K, answer the question. 3 marks. So proportion is quite nice as long as you memorize the formula. The formula for that's inverse proportion. Direct proportion would be y equals kx. Okay, so as long as you memorize those two starting points, you can apply them to any question. Okay, question 14. So frequency density histogram we've got here. The table shows information about the weights in grams of some potatoes. This is a frequency table. On the grid, draw the histogram. So histograms are always, obviously, the x-axis is just the weight in this case, so that's fine. But the y-axis is always frequency density. So you need to have a way of working out the frequency density because we don't have that currently. The formula triangle for histograms is frequency at the top, which in this case is the number of potatoes. Frequency just represents the number of something, doesn't it? Frequency density times class width at the bottom. The way that I remember which way round this goes is that frequency is the only one with one letter. That one goes at the top. That's how I remember it for this one. So we are trying to work out the frequency density. That tells me I need to do frequency divided by class width, which is the two things in my table. So frequency density. So this is the frequency here. Normally they write frequency. I don't know why they didn't in this case. This is the frequency, and then the class width is obviously the difference, right, between these two, between the range. So for the number of potatoes, you've got 20 divided by, do you see how the class width is 20? 20 divided by 20 is 1. Then we've got 50 divided by 10, which is 5. Then we've got 60 divided by 10 again, 6. And then 30 divided by 20. 30 over 20 is the same as 3 over 2, which is 1.5, isn't it? So those are my frequency densities. Now that we've worked that out, do you see how they haven't actually given us a scale? They haven't written anything on the frequency density side, so we're going to have to work that out. So I normally count how many big boxes there are. So 1, 2, 3, 4, 5, 6, technically 7. And then do you see how my biggest frequency density is 6? So I'm going to use this one as 6. And obviously that was technically 7, but I'm just going to use one box is 1 in the frequency density. So you just make sure that obviously whatever your biggest frequency density is, it fits on your scale. And now we can draw it. So this is effectively like a kind of bar chart type. It's not like a curve, it's not a line graph, it's like a bar chart type. So the first one is between 50 and 70. So be careful, because see how their graph starts at 40. So be careful, it is 50. 50 is 70 and it goes up to 1. So let's see if it's going to let me draw the line. So across there, obviously yours should be straighter than mine. Again, do it with a pencil and a ruler. So if you need to rub it out, you can. There. And, oh gosh, it's fiddly, isn't it? Something like that. Obviously yours will be better than mine is. That's the first one, and you just do the same for all the rest of them. Okay, so the next one is between 70 and 80, so that's not as wide, and then it's up to 5. So, there. Across by just 10, and then down again. Then the next one is up to 6, so I'm going to go up again. And that's also across only by 10. So just be careful, because a lot of them are different, widths as well. And then the last one is up to 1.5, but it's across by 20 to 110. So make sure you have labelled your y-axis, your frequency density axis. There we go. Okay, 3 marks, but you do have to work out frequency density first by using that formula triangle and dividing. Okay, so that's quite an easy one if you can just memorise to do that. The diagram shows a sector of a circle of radius 18. The length of the arc is 4 pi centimeters. Work out the value of x, so work out the angle. So we're going to have to do some reversing here, but what I tend to do is, whatever the context is, write that formula. So the context here is arc length, not area of a sector. It mostly is area, isn't it? So just be careful. It is arc length, not area. So the formula for arc length is the formula for the whole circumference, which you might write as either, I know circumference is either pi d or 2 pi r. Doesn't matter, whichever one. I probably would use 2 pi r in this case because we've got the radius. But it doesn't really matter. 2 pi r, and then you multiply that by the angle, which we normally call theta, over 360. That's our formula. Now I'm going to fill in the information that I have. So obviously I know the radius is 18. Obviously, if you chose to do pi times diameter, then you'd have to just double the 18. That's fine. Don't forget to do that. And then the angle I don't know, but that's my x, isn't it? So put x there over 360. But I can put it equal, because that's technically equal to the arc length, but they've actually told me what that is. So do you see how now I've got a complete equation? The only thing missing is x, and that's the only thing they've asked me for. So now all I need to do is just rearrange it, solve it. So as long as you start off with that context and the formula, then it's easy from here. First thing I tend to do is go, well, they both have pi on, so I can divide by pi. Cancel that out. Let's do 2 times 18 is 36, isn't it? And do you remember how we said in one of the other questions, if you're multiplying by a whole number, you can make it into a fraction by putting it over 1. So 36 over 1 times by x over 360. Do you see how that would just give me 36x over 360? So I'm just going to write that, 36x over 360. I'm just kind of showing you, you know, an explanation as to why I've got that. And then is equal to 4. Now this fraction I'd probably just, because some people, you can obviously times by 360 if you want, but because this is a non-calculator, I would rather just have fewer, or like I'd rather have smaller numbers, wouldn't I? So you can times by 360 if you want. I would rather just deal with smaller numbers, so I can actually simplify this fraction, because 36 divided by 360 does simplify quite nicely to 1/10, doesn't it? As in x over 10. That would simplify. And then you see how much easier it is to then just times by 10. There's obviously loads of different ways to rearrange it, but as long as you've got the answer that x is 40, then you're fine. You might have rearranged it differently to me, that's also fine. That's just the way that I thought to do it. As long as you get 40, then you're fine. So that's a nice 3 marks if you know the starting point of the formula. I'm pretty sure the circumference formula is on your formula sheet, so you can use that and then just apply the logic of the fact that it's a smaller proportion of the whole circle, of the whole circumference, which is the angle divided by 360. Okay, question 16, we've got algebraic proofs. So they said prove that the left-hand side, you know how they call it LHS, left-hand side, is the same thing or is equal to or can be written as the right-hand side. So they've given us a starting point. Obviously, we could just expand both and hopefully they would meet in the middle, wouldn't they? You could do that. You could expand the left-hand side and try and get it into the format of the right-hand side. The only reason why I'm pausing on that is because I don't really like the factorizing of this side personally. So I think what I would do is probably just expand both sides and then hopefully in the middle they would be the same thing. And if they're the same thing at some point during the working out, then they must be the same thing at all points, mustn't they? So that's probably what I would do. Now, expanding this left-hand side, just don't forget that it is double brackets. It's not, you know, it's not just 2m squared and 1 squared, it's double brackets for each. So even if you're not sure what they mean by prove, you can always just expand. I mean, even if you don't go anywhere with it, that's still going to get you at least 1 mark, isn't it? So that's one side. The other side, we can also expand, but I'm just going to work on this side for now. So that's 4m squared. Technically plus 2m, isn't it? Which is plus 4m plus 1. Don't make that 2, that is just 1. Minus, I'm going to leave this in brackets because then I can subtract it afterwards. Obviously 4n squared. And then this time it'd be minus 2n, which is minus 4n. And then that would become a plus 1, wouldn't it? There. And then you could obviously subtract, and they're not the same, they're not like terms, you can't literally subtract the m's or the n's, but all of those symbols inside the bracket would technically change, wouldn't it? Be 4m squared plus 4m plus 1 minus 4n squared plus 4n minus 1, isn't it? I guess technically the 1's also cancel, don't they? Those are like terms. Let's just have a look at the other side. So you can either times this first bracket by 4 and then multiply it by the second bracket, or you can times the 2 brackets together and then multiply by 4. But as long as you don't times both brackets by 4, then that's fine. I normally tend to leave that out the front. So expanding this would be m times m, which is m squared. M times minus n, which is minus mn. And then m times 1, right? Because there's also a third term, which is just plus m, and then move on to the n. N times m is plus, I'll write it in the same order because it's alphabetical. N times minus n is minus n squared. N times 1 is plus n. Now you can see that the mn's cancel, don't they? So that's not there anymore because obviously on the left hand side we didn't have that, so luckily that's not there anymore. And then you end up with 4 brackets m squared minus n squared plus n. And then I could expand that. You see how that would be 4m squared minus 4n squared plus 4. Oh, I've missed one, haven't I? Hang on, don't miss anything out. Should be 4 terms. There's an m and there's an n. Plus 4m plus 4n. And then as I said on this one, you see how the 1's cancel each other out. Because 1 minus 1 is 0. And then I could just write it in the same order. So plus 4m minus 4m squared plus 4n is the same thing as on the other side. 4m squared, I'm just going to rewrite it in the different, just so the order matches. All the symbols are the same. And because those two sides are the same as each other, it proves that the originals are also the same. That's probably what I would do, because I feel like trying to factorize this is quite complicated. Like, as in, you get to this point and you'd have to factorize it back there. If you feel like you could do that, then great, but I'm not so sure. I would feel super happy with factorizing with 3 terms in one of the brackets. That's not really something we've learned, is it, as such? So I would probably leave it like that and go, well, those are both the same, so therefore it's obviously the same. I don't know if we need a conclusion, so let me have a look at the mark scheme. Final answer for complete proof without any errors uses expands both sides to show that the left hand side is equal to the right hand side. Yeah, there's nothing you can really conclude there. Inside the brackets on step 2, this bit here, yeah, this bit here, because you see how it was originally, we were, obviously the first double brackets is fine, isn't it? It's all positive, everything. The second double brackets, we were subtracting whatever is inside. When we expand those double brackets, the second lot, we're subtracting all of that. And when you subtract, it's the same as a negative, isn't it? So do you see how I'm subtracting 4n squared, so that becomes minus 4n squared. I'm subtracting also negative 4n. So if I subtract negative 4n, that's a double negative. So that one becomes positive. And then I'm subtracting 1, so that's just minus 1, isn't it? Yeah, that's why I put the brackets here, because I feel like that's such an easy thing to miss. So even though I'm expanding this 2n minus 1, 2n minus 1, I'm going to keep that in brackets and then deal with the negative afterwards so that I don't forget. And I think they do that quite a lot because it is kind of a trick question, isn't it? Like, they know that people are going to get caught up with the expanding and forget about the negative, and I feel like they've done that deliberately. So yeah, just be really careful. If that said plus originally, like, if this bit was a plus, I wouldn't have bothered with the brackets here, because it's all plus, and then it would just, the symbols would be the symbols, wouldn't they? But because it was minus, it was subtract. I put it in brackets to then remind myself, once I'd expanded and simplified it, I then had to subtract each of those terms one by one, which would change, therefore, each of the term symbols, whatever they are, it would change them to the opposite. So yeah, I feel that's a bit of a trick question, that. But yeah, I've seen that quite a few times. Not necessarily just in proof, but just in other expansions and things like that. Yeah, just be really careful. So that's 3 marks just to expand, basically to expand and simplify both sides correctly. You get 3 marks, so that's quite nice. Okay, part B. Sophia says that the result in part A shows that the difference of 2 squares of any 2 odd numbers must be a multiple of 4. Is Sophia correct? So we obviously didn't factorize it, but let's just come back to the original. So she's saying that it shows that the difference, okay, in other words, difference means subtract, of the squares of any 2 odd numbers. Now, if you think about proof, they've used 2m plus 1 and 2n minus 1. In terms of algebraic proof, we should just have this memorized. Even numbers are always represented. It doesn't really matter which letter you use, but you know how in one of the other questions I said that even numbers are always multiples of 2, aren't they? So if you put 2m, for example, that's an even. Whatever m is, whatever I substitute in instead of the m, if I then times it by 2, it's always even. So that represents even. So therefore, if you know, okay, well, that base is even, if I do 2n plus 1, any even number, if you add 1, you're then going to get an odd number, aren't you? Or if you do minus 1, like the other one was 2n, they used n, obviously it's a different letter, that doesn't matter. They got, this is even, 2n is even, and if you take away 1, then that's just like the odd number that comes before it, isn't it? So, that's what she's saying. They've then so these are odd numbers, they've then squared them, and then taken the difference. So that's what she's saying, shows that the difference of the squares of any two odd numbers must be a multiple of 4. So this bit's the right hand side. It doesn't matter. I get my highlighter. I literally don't care what's in these brackets, right? I don't care what's in the brackets, because if I then multiply all of it by 4, it's a multiple of 4 by definition, isn't it? It doesn't matter what's in the brackets. If you factorize out 4, in this case they've got 4 on the outside, it's a multiple of 4. So they've said, is she correct? Yeah, she is. Obviously, yes is not going to get you the mark. You have to give a reason. So, yes, I would say, I would make that reference. I would say 2m plus 1, whatever they've used, and 2n minus 1 represent, or just are, represent odd numbers, because that's just a mathematical fact, isn't it? Just a mathematical fact. Represent odd numbers. And then you could say, so that's one thing. So we're showing that, yeah, we are squaring odd numbers and subtracting them. And then on the right-hand side, I would say, and the right side, or the right-hand side, is a multiple of 4, just by definition, by the fact they've factorized out 4, is a multiple of 4. So yeah, she's right. Okay, so for algebraic proof, you normally need to know like this kind of logic here. I do have a video on that though, if you wanted to look into it in more detail. Okay, question 17. Obviously, you're going to get some kind of either fractional power, negative power, maybe a mixture of both. Again, most likely this is going to come up in non-calculator papers, so obviously revise this before the non-calculator specifically. So work out the value of 8 over 27 to the power of 4 over 3. So you just have to memorize how fractional powers work, basically. So fractional powers, the denominator you always do first, and that is a root, obviously depending on the number, either square root, cube root, any other types of roots. Now they won't make you square or cube root any numbers that aren't already square or cube numbers, right? They're not going to make you work out decimals. So you need to be familiar, obviously you should obviously know your square numbers, but you should also be familiar with, I would suggest, cube numbers up to 5 cubed is what I would recommend you memorize. So here, the first thing I need to do, and when it's a fraction, you just cube root both numbers, right? Separately. Cube root both of those, they are both cube numbers. And then the numerator you do second, that just applies as a normal power. So first of all, cube root 8, which is 2, should know that. And then cube root 27, which is 3, also should know that. It's not like you have to physically work out how to cube root something. You should just have the answer memorized, if that makes sense. And then to the power of 4, obviously, to the power of 4, both numbers. So 2 to the power of 4 is just 2 times 2 times 2 times 2. So that's 16. You can work that out. You could also work out 3 to the power of 4, but I would also recommend maybe memorizing just that one. 3 to the power of 4 is 81, because that's the same as 9 times 9, isn't it? Which is 3 squared times 3 squared. So, yeah, I would probably recognize 81 not only as a square number, but it's also 3 to the power of 4. That would probably be helpful. So 16 over 81, there was no negative power, so we didn't need to do anything with that. It was just fractional. That's a nice 2 marks if you can memorize the steps. Okay, question 18, we've obviously got some circle theorems here. A and B are points on a circle, centre O. D, B, C is a tangent, as you can see. They've given us the angle AOB, which is x. We need to show that angle ABC is a half x, or can be written as a half x. So that's this angle here. So normally circle theorems, there's multiple different ways to do it. So, you know, we could all have different answers, but as long as we obviously get to the point where you're showing it's a half x, then that's fine. The way that I did it, and actually I think a lot of people don't really know this, but you can always draw your own lines if you want. Like you can annotate this. So what I did, because the x to me is giving like, what was it, angle at the centre. So I was like, I really want to draw that then. So this is what I did, is I just drew from B and A. I just drew that, because they will also accept things that are drawn on the diagram as well. Right. I just labelled it E, just so at least I had something to mention. That one, so you know the arrow-shaped circle theorem, angle at the centre is double the angle at the circumference. So this one is a half x because of that. So I wrote down here, I think they'll also accept it from your diagram if your diagram is clear. The reason why I labelled it E was so that I could at least write down angle AEB. You can label it whatever letter you want. Is a half x. Now they have said give a reason for each stage of your working. So the reason for that is what I just said. Angles at the centre are double angles at the circumference. Yeah. And then from there, because when I saw this, the angle we actually want, ABC, do you see how it's touching the tangent and then it's going through the circle into effectively a chord? That to me, and not in the original format, but now that I've drawn this triangle, was screaming angle, alternate segment theorem. That one. The one where you've got the tangent and then a triangle. So that's also why I wanted to create a triangle. Now, alternate segment theorem, the opposite angle, so not A, but E, this angle, is the same as this one. And then vice versa, if I get a different colour, for example, like this angle outside here would be the same as this one. So it works both ways. But in the case that I've done, luckily the one that I have, E, is the same as the one that we actually want. So then I just literally said, so therefore ABC, which is the one we want, is a half x, and then I wrote down y is literally just you don't have to explain what alternate segment theorem means. You just have to say alternate segment theorem. That's what I did. You might have done it a different way, you might have found different ways. As long as you can obviously use circle theorems to prove that, then that's fine. Now they've given you 3 marks. Now what you get for that 3 marks, just so you know how it's distributed, is 2 marks for your working. So you can see I've got 2 stages. Whatever 2 stages you did, you might have done different ones, that's fine. And then there's 1 mark for obviously the fact that it should be correct, but also for writing, they've said 1 circle theorem. Now, technically they say for each stage of your working, so I wrote down 2 just to be safe, but I have seen in the mark scheme they normally only look for 1. So yeah, technically you need 1. I wrote down 2 just to write down. Yeah, this live will be, it will post itself. Like once we finish, it will post itself. You can refer back to it. Obviously it's not like edited or anything. And also all the other lives I've done, all the other papers I've done in the last 3 weeks are also, that's absolutely fine. You can watch it later. All the other lives I've done for the last 3 weeks or so are also on my page. I don't know if there's like a live section, or I've made a playlist of lives. So you can go through all of those as well. There's also other ones. So yeah, it will upload itself automatically. If you don't see it today, check tomorrow, but I think it does automatically upload straight away, but just double check by tomorrow, it should be up. Okay, so yeah, 2 marks for your steps of working, and then 1 mark for obviously the fact that you did get to the correct angle, half x, and for the fact that you've written 1 circle theorem, and they've kind of underlined specific words that they want you to include. So if you memorize these specifically, then it should be fine. So yeah, they have got like 3 different ways that you could have done it. I think 3 or 4 different ways. You might have done it differently to me. That's also fine. Okay, question 19. We've got what I would class as algebraic fractions, but obviously it's an equation one we're solving. So we want to solve this. Now they have actually given us a clue. When you've got 2 fractions and both have x in it, and it's obviously a solve situation, I already know that that's going to be a quadratic at the end. So I already know that. That's one thing. Now, normally when you solve quadratics, normally the first step, or the first thing you would attempt to do is factorize. The reason why I'm not going to do that for this one is, can you see that they've written, give your answer in the form a plus or minus, obviously plus or minus because quadratics you get 2 answers, a plus or minus b root 2. That I'm not going to be able to factorize that, am I? Not going to be able to factorize that. So that's just hinting to me that I'm going to have to use a different method to solve my quadratics, whether that's quadratic formula, which I know you're probably thinking, how do I do that? This is a non-calculated paper. You just have to write the formula, and then, because it's a fraction, you just have to simplify it. You obviously are not going to work out a square root or anything. You're just going to simplify it. Or I think you could work it out by completing the square and solving it that way if you wanted to. So there's those two options. But either way, this is already screaming at me. It's going to be a quadratic, but I can't factorize. That's kind of the information I'm initially getting just from looking at the question. So at least I know where I'm headed, right? Okay, I'm just going to rewrite this here just so I can see it. Now, I obviously don't want fractions when I have an equation. It's kind of annoying, so I'm going to try and cancel out the fractions, which means you need to multiply by the denominators. So normally I would probably just do this in one step, but just to make sure we don't make any mistakes, I'm going to do it in 2 steps. Multiply everything by x, not just one or the other side, but all 3 terms. So the first one, if I times it by x, you see how that would just cancel out the x denominator, and I'd be left with the numerator, which is 1. The next one, when you multiply by x, which in this case, imagine that that's a whole number, it only affects the numerator, so that would be x over x plus 1 for now. Obviously 4x. Then I would go through and multiply by x plus 1 to cancel out that denominator. So again, each of the 3 terms by x plus 1. So 1 times x plus 1 is obviously x plus 1. Now don't forget that this is a minus. And then if I times this whole fraction by x plus 1, that's obviously the whole point is to cancel out the denominator, so I'm left with just the x numerator, but don't forget that it is negative. And now this is where my quadratic is going to come from. I have 4x here, multiplied by x plus 1. Do you see how if I expanded that, I'm going to get x squared? That's where it comes from. Sometimes you end up with double brackets here, but either way, it becomes a quadratic. So the left-hand side, x plus 1 minus x is obviously just 1. Might as well simplify that whilst we're there. And then expand this, 4x squared plus 4x. You see how I've got a quadratic overall? So obviously solving quadratics, whichever method you're going to use, whether it's factorizing, quadratic formula, completing the square, we want all of the terms on one side. I tend to choose the side where the x squared is positive. That's just my own personal preference. So I'm going to move the 1. Obviously I need to subtract it. Now, this is where normally you would kind of think to factorize, but the question's already told me that I can't, but also looking at it, how are you going to factorize that? That's literally impossible. So I'm not going to factorize. I'm going to use quadratic formula. As I said, you could complete the square if you wanted to, if you felt comfortable doing that and solve it that way. That's also an option. Your quadratic formula is obviously on your exam formula sheet, but I will write it here anyway. B squared minus 4ac over 2a. Obviously, I've written it in the order of x squared x number. So that's a, that's b, that's c. Do include the negatives if there are any. So x is equal to minus b is minus 4. The only thing to be aware of there, if b is already a negative, it would become positive, right? Because it's a double negative. In this case, there's no issue. Plus or minus, because we always get 2 answers. B squared minus 4 times, not just 1, but minus 1, so just be careful of that, over 2 times 4. You see how I can now just kind of work through this and simplify it? Obviously, we can't type it in the calculator, that's fine. So I would get here 16, and then I've got 4 times 4 times 1, which is also 16, but I've got 2 negatives, which becomes positive, so that's 16 plus 16, isn't it? Which I might as well work out here in this line here. That becomes 32. So in your brackets, you should, in your square root, you should have 32, obviously over 8. Now, the only thing though is, if I come back here, do you see how, I mean, first of all, they've said root 2. I've got root 32. So this is also now linking to surds. Sometimes this can actually overlap with surds. I've seen this twice or 3 times now. Overlaps with surds. I need to simplify this surd. So leave the rest of it for now. Simplifying surds, you have to find a square number factor. Now 32 has obviously 4, but ideally you want the biggest one. The biggest one is 16. If you chose 4, that's fine, but you'd have to simplify it twice. So it's just saving time if you can think of the biggest one. Over 8. You see how that would obviously square root? That's the whole point, isn't it? And it would become 4 root 2. Okay, so we've got the root 2. The last thing is then the format of the numbers in front. You see how it said a and b? Normally they say integers. In this case, it's not. A and b are fractions. So, and I don't want it as a whole fraction like this. I'm just going to split it. So it's basically minus 4 over 8 plus or minus 4 over 8 root 2, which those obviously simplify anyway, don't they? You might have simplified it already. That's fine. You should get minus a half plus or minus positive a half root 2. That's your final answer there. Minus a half plus or minus, because you get 2 answers there, half root 2. It's kind of messy, but that's what they've asked for, so that's the answer. It should be negative half at the front. Okay, so it's not only just algebraic fractions, it's not only just solving quadratics, it's also simplifying surds. They've asked all of those in one question, which I guess is why it's 5 marks. Okay, question 20. I feel like there's always some kind of probability question towards the end, isn't there? So Alfie has 11 cards. He has 3 blue cards, 7 green cards, and 1 white card. Alfie takes at random 2 of these cards. Work out the probability. He takes cards of different colours. This here is telling me I'm going to use a tree. You don't have to, if you can kind of figure it out in your head, you don't necessarily have to draw a tree, but I like to visualise it, so I always tend to draw a tree. That is technically your choice. We have enough space to draw a tree. So we want 1 set of branches for his first card, 1 set of branches for his second card. Now there's 3 colours, so I obviously need to split it into, try and give myself enough space. 3. So blue, green, and white. Now we obviously need to create the probabilities here as well. This is his first card. So he's got 11 cards. Initially, that's going to be our denominator, and blue is 3 out of 11, isn't it? So 3 out of 11. Green is 7 out of 11, and white is 1. So that bit's fairly straightforward. It's then the second bit that's interesting. So I'm going to try and move it up here. For his second card, because it says Alfie takes at random 2 of these cards, he literally just picks up 2. That's kind of suggesting to me that he hasn't replaced it. You know how sometimes they say he takes a card and then he replaces it and then he takes another. They haven't said that. So I'm going to assume that he does not replace the card. So when he then goes to pick his second card, so following this line here, he's already got a blue one, so that's no longer there. So I've only got 2 left, but also there's no longer 11 cards left. There's only 10, because he's currently holding 1, isn't he? So do you see how the second branches, all of them are going to be out of 10, not 11. Okay, and then green, because again we're following that blue one first, green is still 7 out of 10. There's still a white one left. And you can check, because this should all add up to 10, the numerators. That's fine. Then you go along here and just do the same for all of them, basically. So if he's picked a green, if he picked a green first, then he still has 3 blues, doesn't he? If he picked a green first, then he's only got 6 green left. And if he picked a green first, there's only 1. Well, there's still a white left, isn't there? Again, out of 10, because he has already picked 1. And then lastly, obviously try and do this a bit more neater than I've done it. If he picks white first, he still has 3 blue. If he picked a white first, he still has 7 green. If he picked a white first, there's no more whites, are there? So technically, I guess that one's not even, you could put 0 if you want, but that's not even a branch, is it? He's only got 1 white, so he can't pick 2 whites. So that's my tree. Obviously, hopefully yours looks a bit nicer than mine. Now, what have they actually asked for? They've asked us to work out the probability that he takes cards of different colours. So there's 2 ways to do this. You can highlight all the options where they're different cards, like the first one is different to the second. That's probably what I would do. Or, because that's most of the options, you could highlight all the options that don't satisfy that. So you could highlight both blue, both green, and then subtract that from 1. If you wanted. Sometimes it's less work, but sometimes that's more complicated. So it's up to you. If that makes sense to you, and you want to do less work, then just work out the probability of blue and blue, green and green, and subtract it from 1. Just obviously remember to subtract it from 1. If that doesn't make sense to you and you'd rather just stick to one consistent method, then I'm going to do that. So I'm going to highlight the options that obviously do satisfy what they've said, different colours. So for example, he could do blue first and then green. He obviously can't do blue and blue. But he also could do blue first, then white. But then he also could do green first and then blue. See how this is the problem, is there's quite a few options. He could do green first and then white. And then he could do white first and then blue. But also, I've run out of colours, I'm going to use the same one again. White first and then green. Do you see how the only ones that aren't highlighted are the blue, blue, green, green? So if you wanted to do that and subtract it from 1, go for it, that's also fine. I'm just going to kind of show you everything. So we've actually got, 6 options. We're going to have to work out probabilities 6 times. So when you've got a probability tree, you always, every single time, you multiply between the branches. So what I mean by that is, let's say the yellow option here. it's 3/11 times 7/10. You always multiply them because it's saying blue and green, which means multiply, which is obviously 21/110. And then we've got blue and white. So again, 3/11, but now times by 1/10, which is 3/. The benefit of this is that they all end up having the same denominator, so I wouldn't simplify anything, I would just leave it. Okay, now the blue option is green and then blue, which is 7. It's all the same combination of numbers, really, just in a different order, which is again 21/110. The pink is 7/11 times 1/10, which is 7/110. And then 2 more. Orange, 1/11 times 3/10. We've got another 3/110. And finally, yellow again, we've got 1/11. That's not 11, that's 10. 1/11 times 7/10. 7/110. So you see we've got 6 different options, 6 different possibilities that would satisfy picking 2 different cards. So if you end up with doing your probability tree and you end up with more than one option, sometimes it's only one option, and that would just be your answer. Here we've got 6 options. Because they are options, it's either blue and green, or blue and white, or green and blue, and so on. This is now the OR rule. So if you have options at the end, you always add them, which is why I was saying it's quite handy that they have the same denominator. So I've got 21 plus 3, which is 24, plus another 21, which is what, 45, 52, 55, 62, have I got that right? Yeah, 62. Now you can obviously simplify that if you want, but you don't have to. When it's probability, they don't tend to ask you to simplify, so you don't have to. You should get 62/110. If you did simplify it, it would be 31/55, just half of that. That's fine. They would accept any equivalent. That's fine. But that's the answer I would leave. So yeah, kind of long, but the thing is with probability trees, it's quite a consistent method. So I think that's good in a way. You've got 3 marks. Okay, we're almost there. Question 21, so you can see here we've got obviously some kind of trig graph. They've said specifically the diagram shows a sketch of part of the curve with equation y equals cos x. So this is the cos graph, the original, just straightforward cos graph. That's the, obviously sin, cos and tan, you're supposed to know not only just what it roughly looks like, but you're meant to know all the coordinates for, so this is asking about that. They said P is a minimum point on the curve, write down the coordinates. So you should just know this. Cos always starts at 1. They always, sin and cos, they both go to -1 and 1, don't they? And every 90, the way that I look at it is it's like every 90, so as in that's 90. This is another 90, which is 180. This is another 90, so that'd be 270, like so on, ... 360. So in this case, we should know that P is, obviously make sure you get the right way around, 180 minus 1. They'll give you 1 mark if you got both numbers, but you wrote them the wrong way around. I think in the mark scheme I saw that they gave you 1 mark for that. Obviously, just make sure you get it the right way around. So yeah, no transformation here, just a straightforward cos graph. Okay, question 22. Immediately looking at this, it's obviously some kind of sine or cosine rule, isn't it? But let's read more detail. So here is triangle ABC. The question is just to work out the value of sine ABC. So sine rule. I know it's sine or cosine rule because it's kind of like a scalene triangle, just like a random triangle. It's not right angled. It's just like a random triangle. They've given me a mixture of angles and sides. So that tells me either sine or cosine rule, or if they're asking for the area. In this case, they've mentioned sine of the angle. So I'm going to use sine rule. So they've said sine of the angle ABC, which is this angle here. So sine rule, we're looking for well, when I say we're looking for the angle, they're not actually asking for the angle, but you know what I mean. When you're looking for an angle, that's what you put at the top of the equation. This is obviously also on your formula sheet. So I'm going to leave it sine ABC over, and then with sine rule, you have to pair them up. So as in the angle with the opposite side. So you see how that angle is opposite 6.5. And the sides go at the bottom. If you're looking for a side, you put that at the top of the fraction. And then you get another pair. So you see how obviously our other pair is sine 30, and then the opposite side, luckily, is 10.7. So I just need to rearrange this to get sine ABC as the subject. They've actually not asked me to literally work out the angle, just sine of the angle, so that's fine. So you'd obviously have to just multiply by 6.5, wouldn't you? Sine 30 over 10.7 times 6.5. Now, we obviously then need to work it out. That's, I guess, the harder bit. So you should know sine 30. This is the non-calculated paper. They will have, they ask you to memorize certain values. This is them cashing in on that, basically. So we should know that sine 30 is a half. Luckily it's a nice number. You could probably also assume that if you didn't know, because they said give your answer in the form m over n, where m and n are integers. They've not mentioned any kind of roots. And the only other number that's not a root, like a root value, is not a third, is a half. So you could probably have guessed that. But obviously if you can remember it, then that's more ideal, isn't it? So you've got half there over, now this is then the issue, we've got decimals. You could do like bus stop division if you wanted, put 0.5 divided by 10.07. The way that I thought to do it is because we've got more fractions going on and they also want the answer as a fraction, is that I thought, I'll just convert all of these decimals into fractions. Now the 10.7 is a little bit harder, but what I did was I then just thought, well, let me just times it by 10 to make it 107 over 10. Because if you did 107 divided by 10, you would get 10.7, wouldn't you? So I just basically times it by 10, or if you need to, 100 or whatever, to make a whole number. You could do the same with this one if you wanted, but I just knew that 6.5 was half of 13. So personally, I just did 13 over 2. Whatever version of fractions you want to do is fine. So now this is still not looking that great. We've got here a divide, keep, flip, change, isn't it? So I'm going to ignore the 13 over 2 for a minute. So I've got half, keep, flip, change, times by 10 over 107. And then also technically then times by 13 over 2. So I can now multiply all of those. I've got at the top 10 times 13, which is 130. At the bottom I've got 2 times 107, which is what, 214? And then double it again, 428 I think you should get. And then, I mean, they haven't necessarily said to simplify it, but I kind of just naturally did because it just halves. So I got 65 over 214. Obviously they're not going to ask for what the actual angle is because you can't do sine inverse in your head. And this is such a random decimal that you wouldn't know the value. So that's why they've just asked for what is sine ABC, but it's 65 over 214 or 130 over 428. If I look, yeah, they've given 65 over 214 as their answer, but they have said obviously or any version of that, any equivalent value. So if you left it as 130 over 428, that would also be fine. Because they didn't specifically say to simplify, did they? As long as you've got whole numbers, that's the main thing. Okay, so 4 marks. Question 23, here are the first 5 terms of a geometric sequence. So we need to memorize what a geometric sequence is. It's where every time you multiply by the same thing. Multiply. So it says work out the next term in the sequence. We need to work out what they've multiplied by every time. Now, from root 5 to 10, not only have we got rid of the surd, so I'm going to assume that they've multiplied by root 5, because the only way to get rid of a surd is if you multiply by itself. But then that would give you just 5, wouldn't it? So do you see how to get to 10 is then double? So I just basically figured out that they'd multiplied by 2 root 5. Which makes sense because you see how if you then take 10 and you multiply by 2, you get 20, and if you multiply by root 5, you get 20 root 5, don't you? But then obviously then the next term, it would cancel out the 5 again, wouldn't it? And so on. So I figured out that the difference was multiplying by 2 root 5, and they said, what's the next term? So I just need to take the 400 root 5 times it by 2 root 5. So 400 root 5 times 2 root 5, basically surds again. You obviously multiply the whole numbers, which is 800, multiply the surds, which gives you root 25, which is obviously then just 5, isn't it? So you then need to do 800 times 5. Multiplying by 5, I mean, you can obviously do 8 times 5, add the zeros, or you can just times it by 10 and then half it. Either way, you should get 4,000. Okay, so that's part A. Part B, we've now got a different sequence. So the fourth term of a different geometric sequence is 5 root 2 over 4. The sixth term of this sequence is 5 root 2 over 8. So we've jumped 2 terms, 4 to 6. Given that the terms of the sequence are all positive, work out the first term of the sequence. So in this case, when they give you 2, as in 2 sentences, 2 terms, 2 pieces of information, it's normally simultaneous equations, isn't it? So as in, I want to set up an equation for the fourth and for the sixth. Now, geometric sequences, I don't know if you've seen this, is a, r, n minus 1. So a is the starting term, r is the common ratio, or in other words, what we've multiplied by, and then n is the term number. So for example, what I mean by that is, for the fourth term, it'd be ar cubed, as in 4 minus 1 is 3. That's my first equation. My second equation is then ar5, 6 minus 1 is 5. And 5 root 2 over 8. Because this is a different sequence, right? So I don't know the common ratio currently. Now, simultaneous equations, you obviously need to get rid of one of the letters in order to solve for the other. We can't get rid of the r's, because one's cubed, one's to the power of 5. Whereas we do have a and a, both a's. So what you can do is just divide them, as in divide both sequences, because then you will cancel out the a's. You can't subtract, because obviously they're not added, they are multiplied by a. So we need to divide. Obviously I would choose to divide the bigger one by the smaller one, right? So on this side, ar to the power of 5, let me write it down for you, divided by ar cubed. Obviously the a's would cancel, that's kind of the whole point. I know we want to know what a is, but we can't work it out initially. And then that's just index laws, isn't it? Do you see how that would be r squared is equal? And then dividing this would give you, just kind of over explaining it basically. You might just be happy to divide it straight away and know that that means the common ratio squared. Also fine. Keep, flip, change again. So many fractions with these non-calculated questions, to be honest. And then that would flip, obviously, wouldn't it? So 4 over 5 root 2. Do you see how the 5 root 2s, like if I multiply them, obviously they would cancel. And then I've got 4 over 8. 4 over 8 is obviously half. So either way, you should get that the common ratio squared is a half. So as long as you don't think the common ratio itself is a half, it's not, it's squared. So if I want to know the common ratio each time, I need to square root that. And that's where it gets less than ideal, is what I would say. So if you square root any fraction, you can square root the numbers separately. So the square root of 1 is obviously 1, and then you'd end up with root 2, but then that's an irrational fraction, isn't it? I need to rationalise. When you rationalise, you multiply by the surd itself. Do you see how I'd get root 2 over 2? That looks a little bit nicer than the square root of a half. So the square root of the half is the same as root 2 over 2. Now, the whole point, obviously, was that I wanted to find the first term. So what I would probably do is sub that, I guess, back into here, and you can rearrange it, or you can divide by this cubed, or, you know, however you want to do it, but you want to work out what a is. So a, and then I've got root 2 over 2 cubed is the same as 5. That's how I would personally choose to do it. And then you see how I've got a is the only letter that is missing. That's the one I want, isn't it? So I can now kind of solve this. So I'm going to actually cube that first before I move it over. So obviously 2 cubed is 8 there. Now, root 2 cubed is, I'll write it over here, root 2 times root 2 times root 2. So that bit would make just 2, wouldn't it? Times root 2, so it's 2 root 2. So you have to be just really careful with this, really happy with surds. And then you could simplify that, couldn't you? That would become 1/4, or like just root 2 over 4. So I'm going to simplify that whilst I'm here. Root 2 over 4. 5 root 2 over 4. Now all I need to do is divide by this fraction. So a is 5 root 2 over 4. Divided by this, which again, we're just back to this whole thing, keep, flip, change. So flip it, 4 over root 2. And then if I multiply across, obviously the 4s are going to cancel. And then you see how the root 2s would also cancel? And after all of that, we get a is 5. Again, you might have had a different method. As long as you get A as 5, then that should be fine. So there's that. Question 23. Question 24. This, I think, is our last question, by the way. Question 24, we're almost there. Here is a solid sphere and a solid cone. I feel like cones and spheres tend to come up a decent amount in non-calculator, even though it's obviously pi, but they tend to just tell you to leave it in terms of pi. So this does tend to come up. So the volume, they've obviously given you the formula. You don't need to know any formulas if they're not prisms. So these are not prisms. Don't need to memorize that. They will give you these both of these formulas. Same with surface area, by the way. So you've got the volume of the sphere, volume of the cone. All measurements are in centimeters. The volume of the sphere, they've said, is equal to the volume of the cone. We need to find a ratio. So I'm going to start with this first sentence here. The volume of the sphere is the same as the volume of the cone. So I can write it as, they've not given me any numbers to sub in, so I'm just going to leave it with the letters that I have. And then a third pi r squared. That's my equation, isn't it, based on the context? Now, because I just want r to h, actually there was another question like this, wasn't there, that we just saw kind of halfway through the paper, where we ended up with an equation. It was the m and the p one. We ended up with an equation. We had to make it back into a ratio. We're going to do exactly the same thing here. So what I want to do personally is I like to get all the r's on one side, all the h's on the other, and then whatever happens with the numbers happens. So in this case, I normally always start off by cancelling out the pi's. Pi on both sides, might as well divide by pi. Then do you see how they're both divided by 3? So I thought, well, if I multiply both sides by 3, that would cancel out the fractions, wouldn't it? So I get 4 r cubed is equal to just r squared h. And then I thought, okay, well, I want to get the r's together, so I'm going to move the smaller one, which is r squared. I'm going to divide by r squared, which if you think about index laws, that would be r cubed divided by r squared, which would leave me with just 1r, as in r to the power of 1. So I've got this. And then if you remember, I said this, once you've got it like this, you just have to swap the numbers. Technically, this is a 1 here, isn't it? So it would actually be 1 to 4. Or the other way is that you move the h over, move the 4 over, and then it is straightforward. So whichever version of this you want, it's exactly the same as that other question, isn't it, actually? I don't know why they've asked it twice. So 1 to 4 should be your answer for part A. I think part B was kind of similar. Yeah, so part B, we've actually got now the surface area. Just be careful though, obviously the surface area of the sphere is the whole thing, but the formula they give you for surface area in terms of a cone is only the curved bit, so that doesn't include the base, which we would need to add. So just be careful with that. So the surface area of the sphere is equal to, this is why they put it in bold, the total surface area of the cone, so not just the curved bit, but also the circle at the bottom. Again, find r to h, so we can set up that equation. So the sphere is pretty straightforward. The cone, though, is the curved surface area, but you'd have to add the circle, which is pi r squared. Now, before we do anything, though, the issue with this one is you see how they've given us find ratio r to h, but we've also got an L. We didn't have that issue with the previous one, did we? We don't want L in our equation. So we're also going to have to deal with that. You're going to have to somehow get rid of the L, and we're just left with... Do you see how, well, yeah, because also we don't have an H, do we? We need to have an H, we want to get rid of the L. So I think looking at this, I think what I did was I just thought of it as Pythagoras. So I just drew a line. Again, you can draw lines wherever you want. Here. Ignore it as a cone as such, just think of that as, that is just a right angle triangle, isn't it? 2D. Think of it as this. Now technically, if we come back, if I scroll up, do you see how originally the height of the cone is the same as this line that I've just drawn? That's the same, isn't it? That's the H. So here, I can label this as H. And then do you see how I could use Pythagoras to kind of basically create an equation for L in terms of H and R, which is the only letters I want. So it would be L squared equals H squared plus R squared. And then obviously if I just want L, then I would square root. That's what I would do. I think there was probably a different way to do it, but that's what I would do just naturally when I first looked at it. And now I can sub that in. because I don't want L, I just want H and R. So 4 pi R squared is equal to pi R and then root H squared plus R squared plus pi R squared. Okay, it's kind of annoying, but at least we've got rid of the L. We've now got only letters we want. So because all three terms also have pi, I can still cancel out the pi's. All three of them have pi, so that's fine if I divide by pi. I think I also divided by R, because that would cancel out this one, that would get rid of this, get rid of this. Let's just rewrite what we've got. So we've got 4R is equal to just the root H squared plus R squared plus R. So then I subtracted the R, right? So I could collect the like terms. So that's 3R. This is what I got. You might have also figured out that L is equal to 3R some other way, that's fine. And sub that in, that would be easier, I guess. Now I'm going to square it, because obviously I want to open this up, don't I? So that's 9R squared, square both sides, H squared plus R squared. And I want to, again, get all the R's together, all the H's together. So I took away an R squared. So that's 8R squared is H squared. And then I had to square root again. So I got root H R is equal to 8. Sorry, root 8. I can't even say it. Root 8R is equal to H. And then you see the format they want me to give it to them in. Because I first thought to simplify the root 8, but actually they just want it as a whole surd, so I left it. They want 1 to some kind of surd. Now this is technically the 1, isn't it? Again, you either just look at it as that and go, I need to swap them, which is the answer. Or if you wanted to do it the other way, again, you divide by H and swap it with the root 8, and then you can just look at it straight across. That's kind of a personal preference. Again, a lot of this is kind of down to whatever makes sense to you. You don't necessarily have to do it certain ways, as long as you get the same answer. So you should get 1 to root 8 for that one. So yeah, and that's obviously in total 6 marks, 2 marks and 4 marks. So that is all of the November 2022 Paper 1 Edexcel, obviously the higher tier one. As I said at the start, we will be going through just Paper 1 papers for the next, what was it, even kind of couple of weeks until your Paper 1 exam. Then after the Paper 1 exam, all of the lives will be Paper 2 and Paper 3, because they're both calculator. If you want to have a look, at this paper, I've linked it down below. I think I've linked the mark scheme as well, so you can look at the mark scheme if you want. You can obviously find it by just searching Edexcel past papers as well on Google. I don't think I've done it yet, but at some point today, later tonight, you can check back tomorrow, I will link any of the topics that I already have my own videos for that have come up in this paper. If you wanted to go through anything in more detail, then I will link all of those by tomorrow. You can come back and have a look. This video itself will re-upload anyway after the live finishes, so you can obviously come back and rewatch certain parts of it if you want to refresh it. Other than that, the next live is on Wednesday, which will be another Paper 1, and on Thursday as well. And on Sunday, I will be doing just like a Q&A, kind of like a quick 1 hour live Sunday afternoon. If you have any specific questions you want to ask, then you can come along to that 4:30 on Sunday. But otherwise, yeah, we'll see you on same time, 7 o'clock Wednesday, 7 o'clock Thursday for the next papers. Thanks for joining me, guys. If you have any questions, obviously at the end, you can link them down below in the description and I'll try and get back to you. Otherwise, we will leave it there.